AI robotics.
AI robotics. Yeah, we changed it.
Okay, so you all hear the rules at the beginning, so it's going to be a 10-minute talk. We're going to let you have 7 minutes to give your presentation and 3 minutes for questions.
Okay.
With the clock. Let us know when you're ready.
Ready. So I know that
See?
sorting in robots is not new, but fast sorting robots have been used in manufacturing plants for years for manufacturing, quality control, and packaging. But an example of this is that Apple used Liam robots to help deassemble 1.2 million phones a year. Amazon used Kiva robots to help them with the packaging and shipping process, and recycling plants used Zen robots to help them with the advanced waste sorting process. Today, sorting robots are like computers in the 1980s before Apple introduced the personal computer. These sorting robots have not been commercialized enough to be put in every personal household. But these robots can do anything can do things in lots of fields. An example of this is that they can do this. They can sort in They can help in the streamlining and automating the baggage handling in airports, and they can help in the medical field. Like if the doctor wanted a forceps, then what he could do is say forceps, and the robot would hear it, and he would move the bin to the doctor, and the doctor could pick out the forceps, and it would be like a robot personal assistant. Now I'm going to show you a demonstration of this program, of the coin sorting robot.
Yeah.
As well as
Wait. You tell me what there's no dotted line.
you take it there.
So the flow chart is you need a coin collection to start the coin sorter, and then what you need to do is once the coin sensor sees the coin, it measures the coin's passing time and it equates the time to the diameter of the coin. This is done by, since the quarter is bigger than the penny, it will take more time for the quarter to pass than the penny. Once it identifies the coin, it adjusts the coin bin, and then it puts the coin in the coin bin. And then it counts the coin and puts it in the EV3 display, and it displays it. Okay, and what's the robot is, we use the Lego Mindstorm's EV3 kit. We use the EV3 programming kit, and what the programming kit does is that it executes the program and it tells what all the other sensors and motors what to do. The sensors that we use for this project is a touch sensor, which what the touch sensor does is that it starts and stops the coin belt. We used a color sensor, and what the color sensor does is it detects the coin and identifies the coin. The motors we use for this is the small motor, and the small motor we use to adjust the bin belt, and we also use the large motor to move the coin belt. And the software that we used for this robot is the EV3 Lego Mindstorm software, which is built on a LabVIEW platform. And this is the software. So this is the main program. The first part of the software is the coin initialization. It initializes all the variables and it starts the coin belt once the touch sensor is pressed. Then the next part is the coin sensing. It senses the coin, and then it takes the time that the coin takes to pass through the beam, and it puts it in a variable called coin time. The next thing is the coin identification. It takes the time of the coin and it puts it in the set, and then if it compares it, then it puts it in the set, and then it identifies choke. And after it identifies the coin, it counts the coin and displays it. So it displays it displays the coins, how much total value there is, and how many total coins have been put into the machine. And oh yeah. And since the comments were not readable, these comments, we put them both here. Nice job. Do you want to see more coins put into it? Yes.
Okay. What happens if you put 2 coins in at once?
It won't detect it correctly. It will probably think it's a quarter if 2 coins are put in right next to each other because it equates the time. But if you put 2 coins in at the same time, this robot's going to put 1 coin.
Have you thought about any modification to use the handle for 1 point?
Yeah, I thought of having something over here so that the coin is always in the center, because right now if something's not in the center, then what happens is that since these coins' diameters are so like similar, the coin's diameter, it would not detect it correctly because it's all based on milliseconds.
Want to like see more people's households and stuff
Yeah.
like that. What kind of applications could it stick for them?
Well, it could sort shelves, like if you wanted to put a certain book on the shelf, you could give it to the robot and the robot could move the bin to the shelf where it wants to go. It could also help in the medical field, as I said. And if you wanted it, if you had like boxes and you were playing with your toys, and let's say you didn't want to clean up, then you could just put the toys in the robot could detect them, and then you could put it in the box where it goes.
So I'm interested in this. How does it compare the time that the coin is?
When the coin is put into the machine, like this, it detects when it sees the coin, and then what happens is that once it sees the coin, it detects how much time it takes for the puzzle sensor not to see the coin, and then it puts that in a variable, and the variable is called up again, since the variable is the time gets put into a switch where the switch detects which one.
Can your sensor tell anything else besides color or besides edges? It sounds like you're detecting
No, I'm not. Yeah, I'm detecting an edge. Once it sees the coin, it detects the edge of the coin, and it does this by reflected light, not by light. And since this is a prototype, this is not 100% accurate. It's 80 to 90% accurate from my experiences.
What modifications might you make to sort out books?
Well, one thing, we could make this larger, because since this one right now is made to sort coins, we could make it larger, and then so that you could put books and stuff. And another thing is that you'd have to change the code a bit, because you can't really, unless you wanted to shelve the books by size, you would have to change the code, and you would have to sort it by something else that the code sensor can detect.
If you have a book or something like that, you know that it has like, you can measure differences in quantity of
Yeah,
sizes.
yeah.
What length do you think is better to measure if you have the things like to detect it and then put it on different? You know that, for example, you have like this size and the smaller size.
Yeah.
Which one do you choose? You want to choose to detect this size, or the diameter? Which one do you think fits?
Well, since it's a rectangle, what it would do right now is that if the book was passed under, it would sense if you were doing it by size, it would sense when it detects the book, and then it would wait until it doesn't see the book, and then it would measure the length of the book or the width of the book, depending how.
My question is that what do you think is better? Which length is better for your sensor? You know that you can have different lengths. You
Yeah.
can have different hooks, which their widths are the same. So
Yeah.
what do you think is better to measure if you want to have like an optimized
Oh.
code? That's the question.
Then it
So
would.
how do you think that it's better to optimize it? For example, you can have different hooks with different widths.
Yeah.
So how do you sort it? Which one is better? Which
Well,
way is better?
if you're sorting books, you might not want to sort it by length. It would really depend on which way you want to sort it. You could sort it by color. You could sort it by brightness. You could sort it by really anything you
So my
want.
question, if you want to just measure the length, what
Yeah.
do you think is better? You know,
I know.
any idea?
So actually, just a final question based on what you said. So, what if you haven't, you think of a way that a person might be able to choose what they sort on, right? Because you programmed an algorithm that sorts by or sorts points a certain way.
Yeah.
What changes might you make to make this more dynamic? Like, if, for instance, there are commands to allow a user to tell the robot
Well,
what it wants to sort by?
yeah. I mean, if you wanted to sort, let's just say you go into the program and let's just say you want to sort books, you can press the up button and the book sorting program, and then you go up to I need to sort books. So then the book sorting program would be the robot. But if you wanted to sort coins, then you can press the down button, and then it would go into the coin sorting program, and then it would sort the coins.
So just a general comment. That's a good answer. So as you think of problem technology, you probably see user interfaces.
Yes.
So one example, sometimes this is kind of set up. There are interfaces where people, programmers already have designs.
Oh.
Maybe
Kan je verleden? Kan je die verleden?
like building blocks, right? Programmers already done that. So maybe you can have them sort by size, by color, by script, like by letters, for instance. Maybe you could design an interface so that a person can just sort of drag and drop.
Yes, we have my blocks. My blocks are like you can choose a whole part of the program. You can select it and you can make it into one little block, and then instead of having the program long and long, you can just edit one my block and you can launch it. Yeah, you can pick and choose.
Good job, guys.
Great job.